Okay, in this one we're going to talk about, it's still on 1.4. This is part 3, still with 3 equations and 3 variables. Now we're using substitution method. Quite frankly, this would be my last choice if I was doing one of these. I much prefer elimination. Now it is easier when you get one like this. Notice here, we actually don't have all 3 variables in all 3 equations. So that's when substitution works pretty well. Because like right here, if you have y equals -3, and here we have an equation with x and y and no z, so what we want to do is just take -3 and plug it in here for y. So if you plug it in there, we have 2x plus a -3 equals 5. So 2x equals 8, x equals 4. So we're already 2/3 of the way done because we know y, we know x. Now we take both of those and plug it into this last equation. So we know x is 4 minus 2 times a -3 for y plus z equals 6. So that's plus 6. So 4 plus 6 is 10. If we subtract 10, we get z equals -4. So our ordered triple, x is 4, y is -3, z is -4. So that worked out pretty easy. And that's when if something's missing, substitution works pretty well. This next one now, there's nothing missing, so it gets a little harder. Now what we want to do is we want to pick one of the equations and solve it for one of the variables. You can pick almost anything. Let's say we pick this last one. I want to solve for x. You could pick anything. We could have done it with this first one. That would have worked fine too. But I'm just going to do it with this. And now, to me, first I'm going to move the x to the other side. So I have 5y plus z equals 8 plus x. Then I'm going to subtract 8. So 5y plus z minus 8 equals x. So I solved one of the equations for x. Now we're going to take that and plug it into each of the other two. This is where you have to be really careful. So I'm going to put x in here. So I'm going to take 3 times all of that, 5y plus 2z minus 8. And now I still have the plus 2y plus 4z equals 17. So if we distribute here, that's going to be 15y plus 6z minus 24. And we still have the plus 2y plus 4z equals 17. Now if we combine like terms, 15y and 2y is 17y, 6z and 4z is 10z, and I have a -24. If I add that to the other side, that's 41. Is that right? Oh, I'm sorry, I put a 2 in there, which shouldn't have been. Sorry. This should have been a 3z. So that makes this 7z. See, that's what I mean about being careful. There I wasn't careful. I didn't even copy the problem down right, what I had down right, and I got off. So that looks good. Now we need to get rid of, we got rid of x. We need to get rid of x again. So we need to substitute into the other equation for x. So let's substitute into the top one. So in for x, we're going to put 5y plus z, try to make sure I copy it down right this time, minus 8 plus y minus z equals 4. Let's see, 5y plus y is 6y. Z plus a -z, that worked out pretty good because that canceled out. That's awesome. Then if we add 8, we get 12. Well, that worked out great because now we have y equals 2. We got one of our variables. Now we can plug it back in and find another variable. Let's say we plug this 2 in. Let's say we plug it in right here. So 17 times 2 plus 7z equals 41. So that'd be 34. So I have 7z. If I subtract 34, that equals 7. So z equals 1. Now we can take both of those and plug it into what we did right here for x. So we have 5 times 2 plus z, which is 1, minus 8 equals x. So that'd be 10 plus 1 is 11, minus 8 is 3, x equals 3. We could plug that in to make sure it's right, like if we plugged it in here. 3 times 3 is 9, plus 4 is 13, plus 4 is 17, so it checks out. Our order of triple is 3, 2, 1. If this hadn't worked out, what we've done is we would have two equations with y and z. We would have combined them to get another variable to cancel out, and then went on like we did before. I'll try not to give you very many with this. In fact, I changed on the assignment for this. I'm going to change the problems for this one. This is on practice number 3. I'll change the problems. Instead of 19 and 21, I'm going to do 22 and 23. So on the practice problems, and you'll see that on Big Ideas Math, you'll do 22, 23, 24, and 28 on those. And that's it.